From 2021 through 2024, artificial intelligence operated within a specific technical boundary. It sat idle, waiting for a human to type a prompt. In June 2026, the industry began deploying agentic models that initiate their own tasks. This node network illustrates agentic infrastructure. It represents systems that proactively manage multi-step workflows across diverse environments. Building this required solving a three-tier bottleneck. A system must simultaneously execute complex toolchains, maintain persistent state, and interface natively with the user's environment. Over a single 48-hour period, xAI, OpenAI, and Apple released 3 updates that address each layer of this stack. Together, these releases form the foundational layers for a fully autonomous digital workforce stack. We start at the base layer, execution. In early June, xAI launched Grok Build 0.1. While previous tools functioned as autocomplete assistants, Grok Build functions as a proactive project manager. The architectural mechanism driving this is full integration with the Model Context Protocol, or MCP. This diagram compares the two models. On the left, legacy AI is locked inside a specific coding environment. On the right, MCP allows Grok Build to connect directly to external toolchains, bypassing proprietary vendor lock-in. This allows the model to autonomously read databases, write migrations, and deploy changes to staging. On the SWE bench evaluation, Grok Build achieved a 43.2% resolution rate, a measurable lead over Claude 3.5 and GPT-4 Turbo. During a real-world enterprise beta test, a Fortune 500 company used the system to modernize a 15-year-old Java monolith. Successfully refactoring a monolith into microservices proves the AI can maintain complex contextual mapping across hundreds of files simultaneously. This project, which would typically require months of senior developer time, was completed in 3 weeks. Utilizing an open protocol like MCP turns the AI into an active network node capable of end-to-end engineering execution. Execution is only half the problem. If an agent forgets a user's parameters between sessions, the constant need for reprompting makes it inefficient. OpenAI's Dreaming architecture provides the solution for the persistence layer. Legacy systems relied on raw conversational archival. Storing every log as unstructured text is computationally expensive. The new Dreaming system uses continuous semantic indexing to condense that data, identifying patterns and discarding filler. This reduces compute costs 5-fold and increases recall accuracy to 87%. That cost reduction allowed OpenAI to push persistent memory to the free tier, making a once premium feature standard infrastructure. An 87% recall rate reliably retrieves work preferences from weeks ago, removing the burden of context setting from the human user. Long-term AI persistence is a result of data structure optimization. Semantic memory has become a baseline requirement for modern agents. The final hurdle is distribution. A persistent agent still faces low adoption if users have to navigate siloed, high-friction applications to use it. Apple addressed this by approving the third-party Poke AI agent for its Messages for Business platform. This approval signals a shift in Apple's strategy. Instead of relying on a Siri monopoly, they are now curating third-party agents. Legacy conversational commerce failed because of friction. Forcing users to open browsers and enter credit cards causes high abandonment. Poke's integration collapses that flow. A request triggers native Apple Pay and biometric authentication entirely within the iMessage frame. By leveraging on-device biometric authentication, the agent bypasses the security and trust hurdles that typically stall third-party commerce. Native OS integration provides a zero-friction deployment mechanism, which is necessary for bringing autonomous agents to the mainstream. This is the completed 2026 agentic stack. It is built on OpenMCP for execution, semantic indexing for persistence, and native OS integration for the interface. This stack demonstrates that our raw technological capabilities have currently outpaced our models for human-computer interaction. This interaction design gap is why Brian Chesky has launched an independent AI lab. Chesky argues that the industry has retrofitted advanced AI into outdated paradigms, forcing sophisticated agents to behave like simple chatbots and phone trees. As core inference logic continues to commoditize, the underlying models are becoming less of a differentiator for the market. The next major moats will be built by those who can decouple that inference logic from current product designs to create entirely new interaction patterns. The events of June 2026 mark the transition of AI from an experimental application into the invisible infrastructure of the next decade.